Hi everyone, it's Mrs. Suter, and today we are doing Science with the Science Lady. We're going to be talking about collisions, and we're going to be watching what happens when the force of an object collides with another object. So as we get started here, I'm going to show you a video, and then we're going to be doing some demonstrations with some things I have set up on my floor in the kitchen, and we're going to be taking some measurements and recording things. Okay? So let's get started with our presentation. So I'm going to share my screen with you so that you can see the presentation here. So we're going to be talking about collisions, and as you see here, you're going to see the two people are colliding, and when they collide, a reaction happens. So movement occurs. So what we're going to be doing is we're going to be looking at these collisions, and we're going to be talking about how the collisions, what effect they have. Okay? So right here is a 142 mile per hour serve, and the tennis racket is going to hit the tennis ball, which is coming at it, and we're going to put it in super slow motion so that we can see what's happening with the racket and what's happening with the tennis ball as they collide. So I want you to watch this for just a moment. Here it is in the super slow motion as the racket comes up and hits the ball. You see the compression because this is a softer tennis ball. It collides in with the strings of the racket, which gives it some extra force, and then it springs off that with the force, and that's what gives its momentum to go across the net. So you can see in super slow motion how the collision occurs with the ball hitting the racket or the racket hitting the ball. So this is what we're talking about when we talk about collisions. Now, what we're going to be doing today is we're going to be setting up our own little lab here on my floor, and we're going to be using a pool noodle to set up a ramp for a marble. And we're going to be testing what happens when the marbles collide. And we're going to be taking some measurements on that collision and see if we can make a generalization or we can draw a conclusion based upon what happens when the marbles collide. Okay, so I'm going to quit sharing my screen so that I can show you how I have my floor set up here. So here is my pool noodle, and I have it up on a ramp over here. You can see that I have some numbers marked off. This is number 1, this is number 2. These will be different starting points of the marble that is going to collide. And it's going to collide with the marble right here that it says start. That's where my first marble is going to be. So my first marble is this smaller marble. And then we're going to have collisions with another small marble and a larger marble, so that we can see and draw some conclusions about collisions. Okay, you will see that I also have rulers set up on both sides of my pool noodle so that I can measure from the start how far the marble that's stationary, which belongs right here, how far it travels. So I'm going to take one of my marbles and I'm going to put it right there at the start. So here it is at my start. Now I'm going to begin, when I put it right here, you can see that the marbles stay at the start position. They just sit there. Now I'm going to take my first marble, which is the same size as the marble here, and I'm going to start it right here at position 1. So it's about halfway up the ramp. I'm going to drop it there, and I'm going to let it roll down and collide with the marble that is here. And then we're going to measure how far this marble travels based upon that collision that we have. So I'm going to start it off, put my marble here at spot 1, and here we see that my marble traveled down from the start. It looks like it made it about 2.5 inches. So on my paper I would mark down that trio 1, which was small marble on small marble on small marble, at spot 1. The collision made this marble stop a little past the start and made the first marble that was resting travel to the 2.5 inch mark. Okay? Now, would you say that the movement of this marble was only because of the marble that was traveling on the ramp? Okay, well, was there any other thing that was making this marble move other than the collision with this marble? Okay, you're right. So we have to say that this collision happened, or this movement of this marble happened only because of the energy that this marble transferred to it. So we have to think about two different kinds of energy. We have potential energy, which is potential energy is energy at rest. So this marble has potential to move if a force acts on it. So right now it's just holding potential energy. It's not using it, it's just sitting still. Now, this marble, as it's sitting here and I haven't let go of it yet, it also has potential energy. But as soon as I let go of it, it now has energy of motion. And that energy of motion, which is called kinetic energy, causes the movement. Then that marble collides with the resting marble to make that marble move. Okay. Now, as you can see, this time when I rolled it down, the collision made this first marble move 4 inches. So the energy from marble at 1 colliding with marble at start transferred the energy from marble 1 to start marble and made start marble move 4 inches. Okay, now, what do you think is going to happen if I take this same marble and move it up here to spot 2? So it's higher up on the ramp. It's going to be here instead of down here. Let me move that. It's going to be up here instead of down here, and it's still going to hit this marble. What do you think is going to happen? The first time when we started it from here, the marble traveled 2.5 inches. The second time when we started it here, it traveled 4 inches. Well, let's try putting it from here one more time. Let's do 3 times and see how it travels this time. So let's start with 1. All right, again, I get about 4 inches. So the first time it collided, it made the resting marble travel 2.5 inches. And the second time it traveled 4 inches, and the third time it traveled 4 inches. So I would be keeping notes of those. Okay, now, what do you think is going to happen when I move so that my marble is starting up here? Do you think it is going to travel the same, less, or more? Make your prediction. All right, so I'm going to put it up here, and I'm going to let it go. This time I can see that my marble traveled 8 inches. So my resting marble traveled 8 inches. Now, let's try that 2 more times to see if we get similar results. I'm starting up here at 2. This time it traveled 7 inches. Try it one more time. Up here at the 2. And this time it traveled 8 inches. So when I put it at spot 2, the only thing that has changed is the position of the second marble, which means because it's up here, it's going to have more potential energy. Therefore, it's going to have more kinetic energy transferred to this resting marble, which then forced that marble to travel further. So we know that the movement of the second marble, the resting marble, only happened because of the energy transferred from the potential energy, kinetic energy marble. All right. Now we see that when I moved it up the ramp, it traveled double the distance. So the further up the ramp, the more energy it has, and when it transfers it, it pushes the marble further. All right, now let's think about what's going to happen if I put my resting marble back, but this time instead of using my small marble, I'm going to use a larger marble. Okay, make a prediction. What do you think is going to happen? Okay, and we're going to start it off at spot 1 again, and we're going to do it 3 times. So I want you to make a prediction. The first time we started our smaller marble at spot 1, it traveled 2.5, then 4 centimeters, or 4 inches, then 4 inches. What do you think is going to happen when I roll the larger? Is it going to travel the same, less, or more? Okay, make your prediction. Okay, ready? This time with the larger marble, the resting marble traveled to the 8-inch mark. So that was attempt 1. Let's put it back. Attempt 2. This time it was a little more than 8, but about 8 1/4. So let's try 3. This time a little more than 8, about 8 1/4 again. So when I used a marble double the size of the original one, it must have had more energy because of its mass, its weight, and that transferred more energy to the marble that was resting, causing it to go further. So now, what's going to happen if I put the larger marble up here at spot 2? When we used the smaller marble at spot 2, this resting marble traveled 8, 8, a little more than 8, and a little more than 8. So what do you think is going to happen this time when I do the larger one? Make a prediction. Is it going to travel more, less, or the same? All right, let's put the marble up here. Let go. Oh, it went all the way to the end. So I have to measure this is 12, 13, 14, 15, 16, 17, 18, 19. It traveled 19 inches this time. Okay, so we're going to do that. I'm going to put this here so that I can get a better measurement. 19 inches, so let's try it again. Put it at spot 2. Ooh, again, 19 inches right to the end. And I think it's only stopping there because of the cut. Let's try one more time. Oh, that time it even went beyond 19. So we were at, this is 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Traveled 30 inches. So what conclusion can we draw about collisions? Okay, what conclusion can we draw when a marble in motion, having kinetic energy, hits a marble at rest with potential energy? What can we say happens? Yeah, we can say that the marble, the moving marble, the marble that has kinetic energy, transfers its energy from this moving marble to this resting marble to make the resting marble then travel. Okay, now the higher up on the ramp that it goes, the more force, the more energy it has to transfer. So then when it collides with the first resting marble, that marble then can travel further because it has more energy. So we now know that more energy is available when I move the marble further up the ramp. Okay. Now, the other thing we notice is when I change the size of the colliding marble to double the size of my resting marble, then we saw that it more than doubled or more, the amount of energy. So because the marble has more mass, as it travels, it has more energy. When it hits the resting marble, it causes it to move even further. So you can see the energy is transferred from the one that is moving to the one that is resting. And we know how much force or how much energy it has based upon how much energy is transferred into the resting marble. Okay, those are some interesting conclusions that we can see if we are doing our experiments. Okay, so remember when you're doing your experiments to do them more than once. All right, so now let's go and talk a little bit more about what we see happening here. Okay, so what will happen if the small marble, what will happen if the small marble is released at the top of the ramp and collides with another small marble? Well, we saw that the small marble at rest moved further. It had more energy. When we ran the experiment 3 times, we could see that the results were consistent. So what changed compared to the initial trials? Well, the first time we put it at spot 1. The second time when we moved it up higher on the ramp, we know that it must have more energy from its position So the only thing that changed was the position of the rolling marble. None of the other variables changed. They were controlled. So is it fair to say that any change that we saw was the result of the motion of the first marble? We can say yes, because that's the only thing we changed. Now, we did the experiment again, and we used the larger marble. When we released it in the middle of the ramp, it collided with a small marble, and it made it travel twice as far as the small marble when it hit it. Then we moved it to position 2. So the only thing that changed this time was the size or the mass of the moving marble. So all of the rest of the variables stayed the same. And so we know that the results have to be because of the change in the size of the marble. And then we change position. So a collision happens when one object runs into another. When objects collide, energy is transferred from one object to the other. And since energy is the ability to do work or make things happen, the amount of energy transferred during the collision depends on the weight and the speed of the moving object, as we saw. Because if we moved it further up on the ramp, it traveled at a faster speed, therefore more energy. When it was larger, we saw that it traveled with more energy, therefore more motion. Now, every day we see and experience hundreds of collisions. A collision could be as gentle as a puppy licking your face, or as dramatic as a wrecking ball smashing into a building. Collisions are part of our everyday lives. People drop things which collide with the ground. Drumsticks collide with drums. Sports involve numerous collisions. Baseball, the batter tries to collide with the bat, collide the bat with the ball. Energy is transferred from the swinging bat to the ball, which makes the ball fly. Okay, we also have bumper cars. Here's another example of energy transferred when the two objects collide. You can see that where they collide, the people in the car are jostled around. So bumper cars, like I just said, all the cars are usually in motion. When one bumper car hits another car, the energy is transferred, and the passenger in the car feels the change in their motion. They can sometimes stop the direction, stop or change the direction due to the impact, and you can get turned around. All right? Now, the faster the object is moving, the more energy it can transfer. And that's why we have things like speed limits on the road. Because if you hit something going at 10 miles an hour, you're not going to do as much damage as traveling at 65 miles an hour. So the amount of energy transfer between two objects depends upon the speed. So that's why we have things like speed limits. So we want to make sure that when things collide, least amount of damage is done. Now we control that by speed limits and enforcing those being followed, and also by special features in a car like crumple zones that will reduce the amount of energy transfer to the passengers. And so those make things a little bit safer. We also know the heavier the object, the more energy it can transfer. We saw that with the marbles. So we know that these two rams, we know that if they are colliding, it's usually the larger animal that ends up winning because it is transferring more energy, therefore does more damage. So if a 300-pound lineman tackles a 100-pound quarterback, the quarterback doesn't have much of a chance. It's going to get a lot of damage. So the same thing with the animals here. Who will be the most successful in the fight? Probably the one that is heavier because it has more mass, therefore more energy. Now, Newton's cradle is another example of this phenomena of energy transferring. And so when you move one ball and it comes down and collides, the energy is transferred through the others, and then the exact same amount of energy is transferred for the last ball. So you can see that the ball on the right and the ball on the left will travel the same, and the energy that is of that motion is transferred through the other balls in the middle. Okay, so how does that go to our challenge? So our challenge is going to be today to build a Rube Goldberg machine. Now, Rube Goldberg was an actual person. He was an American cartoonist, but he had a degree in engineering. And he lived from 1883 to 1970. And he won a Pulitzer Prize in 1948. Now, his cartoons often showed machines that created chain reaction. And the complex contraption did a very simple task. So he made all these machines to do one thing, and that one thing could be something like lighting the candle on the cake. Okay, so it's a complex set of machines that run through and can complete a very simple task. And it's done through transferring energy. So what we're going to do today is we're going to try to build our own Rube Goldberg machine. So here is a video that you could watch about a Rube Goldberg machine, but we're going to actually try to build our own. All right. Now, this is another example of a Rube Goldberg machine, but I'm going to take you and show you the Rube Goldberg machine I set up, and then we're going to see the simple task that I'm asking it to do for me. Okay. So what I have set up here is my own Rube Goldberg machine. I'm trying to see if you can see it. Okay, here I have my boxes, and I have a ramp that I've taped. Here I've created a little device, simple machine, and it is simply made with a binder clip, a pencil, and a marker. So I take the binder clip, I stick the pencil in there, then I take my marker and I put it in so that it makes that pencil stick. Okay, now it is a contraption that when it gets something hits it, it sends the marker flying. That's transferring the energy. Then that marker is going to hit this book, which is then going to hit this book, which is then going to hit this book, and that transfer of energy is then going to hit this, which I just made a little like teeter-totter. I taped pencil to a marker as like a teeter-totter, and the end here I stuck underneath the cup. So when this book falls down, it's going to hit this. It's going to make the cup tip over, and then it's going to dump its contents into the bowl that I have on my chair. Okay, so what we're going to do is I'm going to play through my Rube Goldberg machine, and my object is going to be to put my gummy bears in my bowl. So the first thing I'm going to do is put my gummy bears in my cup. Okay, one left in there. Now, I need some force or something, some motion to get my machine to begin. So, I'm going to start here, move my cup in. So then, I'm going to start off with a battery because it's going to roll down my ramp. It's going to hit this machine, which is going to knock the marker, and it's going to transfer the energy through the books, transfer the energy into the pencil, causing it to transfer the energy into the cup, and then make the cup tip over and dump the candy into my bowl. So let's see if it works. Oh, I need a little more. Maybe I should start with this heavy marble. Oh, still not working. Let me see if I can. Oh, need more power. Okay. Oh, I know what's going on. Could set it like this. Ah! Well, then I got it set off, didn't I? Okay, let's try it one more time. See if I can get my machine to work. It was working earlier. Lost my pencil, flew out of there, so I'll just get another one. Set my little booby trap here. I guess I'm grateful that it didn't knock all my books down, even though I'm having trouble getting my marker to stay in my contraption here. And there we go. Knocked it over, but my cup was taped to the table and it didn't fall over. There it goes. All right, not a perfect attempt, but I'm sure you guys can do much better. So what I want you to try to do is create your own Rube Goldberg machine that will then transfer energy in a chain reaction to create a simple task, to complete a simple task. All right, well, that is what we were doing today. So try to build your Rube Goldberg machine. And then if you get that built, if you'd like to create a video to send to me so I can see it working, that would be awesome. Hope you have more success than I did. Enjoy. Talk to you later.